I'll paint a picture जैसे तू मेरी खबरों के नीचे आगे की सोचूं मैं.
All right, so we're on lesson 3, and lesson 3 is about functions. I have with me Jack Armstrong from Long Island, and I'm from the Long Boulder Island of. Now we have some math again. So I'll pull up my trusty text file, write an equation, y equals f, y equals 2x. That's one way to, so this is an equation in which the independent variable is x, and what x means is x is a variable. It varies.
Okay.
It can take different values, as we just saw in lesson 1, right? So anyways, so it can take different values. So if I give, for instance, well, that's one way to, if I give x the value 3, then y becomes 6.
Okay.
If I give x the value, if I replace x with the value 4, then y becomes 8. Another way to express all of that is, so our function is actually this. So the highlighted in blue is our function, and y is the value that this function generates as x takes on different types of numbers.
Okay.
So, and the better way to talk about like that is this. So f, so it's, let's read this, okay? So I'm gonna, actually, let's just stay here. So what is the function actually? What is the literal function? The function is 2x. What is the name of the function? We are calling this function f. Okay, let me write it to make this clear. Let's see. I'm going to write another function, and this is a function that looks like this: x raised to power 2. That's how you write that, right? Okay.
Yeah.
Okay. So x raised to power 2. So this is a function that squares whatever x. So if x is 3, then we get 9. If x is 4, it squares the 4, and you get 16. 16, right? So so now, what name should we call it? We could call it g, right?
G of x.
Yeah. So if somebody said, hey, x to 2, this function, what is its name? Well, if you look at this equation here, the name of that function is called g. Of course, in Python, we don't use function names like we do in math. We would call this the square function.
Okay.
Right? We would say, hey, so if somebody said, hey, what is the name of this thing? Or what's the name of this function? It's called square. What is the name of this? I could call this double it.
Absolutely.
Yeah. Okay. All right. So there we go. So this is our first slide. Now, this is all math, right? We were doing math. The only part where it became computer science is when I started using square rather than G or F or H. Okay. So now let's get back to our problem. In other words, you can go from mathematical functions to computer functions almost seamlessly in Python.
Okay.
And that's why Python is a favorite language of scientists and engineers and mathematicians.
Effortless. Okay. Got it.
It's effortless. So let's write this in Python, and we can do that over here. So remember that keyword def. If I hit enter, let's see what the compiler will tell me what def is. Aha, it says invalid syntax, which means that, so line 1 is this line.
Yeah.
And it says where are we? We are in standard in, as in the display.
Okay.
So in other words, we tried to input DEF to the compiler, and the compiler said that you can't just give me def, you need something else along with it. So keyword that goes when we are defining a function. So let's call our function f. So now we have the keyword def followed by the name of the function f, and does it take any value? Does it have? So now doesn't this look exactly like the math one right there, right? And then so this is, at this point, all we know is that we are defining a function that takes one argument, x. We don't know what the type of that argument. It could take integers, strings. X could be a reference variable to a string. It could be a reference variable to an int, to a float. Who knows, right? But the name of this function, we're calling it f. And then the next key thing, syntax that we need to do is the colon. And then we hit enter. And then we have to do 4 spaces, otherwise it won't work. Because functions, the block of code that is indented is how we see functions. So we're going to indent 4, and you'll understand that in a second. Actually, in a couple of slides. 1, 2, 3, 4. And now I'm going to write my function. Let's say this function just returns 2 times x. So now what's happened is, now if I read this, I'm saying, I'm defining, using this keyword, a function called f that takes an argument, and when I run this, it will return that argument,
Okay.
product of the argument times 2. It will double it.
Okay.
Now if I hit enter, I'm going to get 3 more dots. See, the dots are different from that. So I need to enter one more time. And now, if I, now the function f is defined.
Okay.
Now I can call it. So I'm going to call it by doing this. And when I hit enter, x will be assigned the value 4. So when I hit enter, f is now a name, just like a variable name. And in the memory, f is a memory address. It's like a reference variable now.
Okay.
And it is now pointing to a place in the memory where this code is sitting. And therefore it can then so when you do f of 4, when you pass in the value 4, x gets assigned the value 4, and everywhere in the body, this is the body. The body of our function f is only 1 line long. This x will be replaced. So now when the compiler goes inside here, when it's evaluating it, it goes, what is x? It's a reference variable. What value does it hold right now? This is replaced by 4. 2 times 4 is 8, and that will be returned. So this return thing will take all of this and replace it by 8.
All right.
Okay. All right. So let's keep going here. Okay. So that was our preamble. Here is our function again, f of x, that doubles whatever you send it. And this is what it will look like in Python. Okay. So let's keep going here. So this is the math. This is the Python. Here, I'm trying to draw analogies of how Python syntax mirrors the language of math. So the f of x is right here. This equal to becomes the colon here, and then the function itself is here. The function itself is the whole body of that. But anyways, let's keep going. And then here we have all of this again. We had a 1-line version of a function that doubled whatever you passed it in, and now we have 2 lines. So let me see what's happening here is that we have a function called f. It takes the variable x. And so when we call it, Actually, let's go to the where we call it and go through that. All right, here. So I have my arrow. So you are typing it out, let's say over here on the interactive section session, or you typed all of this, put it in a text file, or you're using Spider. When you hit run, the compiler wakes up and it's going to go through. So the compiler at the beginning, so let's say this was in a file, or it was in, let's say it was in a file. The compiler starts here, reads the first line, and it tells itself, hey, I think what's going to follow this is the definition of a function which has been named f. And so then it goes here and says, okay, the first line in this function that has been defined by the user is going to be this statement, which is an assignment statement. And then the second line of this function will have a statement which we call the return statement. Whatever y is, y will be returned. And then it goes here, it tries to process this, and the Python compiler says to itself, oh, it's an empty line, so I don't need to do anything. And then it comes here. Now when it reads f, it goes, looks in its memory, finds f associated with this function. And so it says, oh, it's a function call, obviously, with a argument, a parameter that is being passed 3. So as soon as it reads this, where does the arrow go next? It has to go back in the memory over here. And then here, the x gets the assigned the value 3. Then the compiler goes to the first line in the body, does the math. It multiplies 2 with what is the value of 3, which is 3. What is the value of x, which is 3 right now, assigns it to y. And then the next line returns the y. And when this line hits, this whole thing, well, if this was inside a print statement, 6 would get printed out. So now let's look at, so this is our first call, function call with 3 as an input. If there was nothing after this, nothing would happen. So let's try that. So I'm gonna write this here quickly. Okay, and when you're using the interactive session, you have to actually count this. 1, 2, 3, 4. Y is assigned the value 2 times x. Second line of the code, 1, 2, 3, 4 is return y when you're done. And so now we have defined our function, and now I'm going to call the function, right? If I call the function and send in 4, what will it return?
8.
8, okay. When I hit, here is 8, all right? And, but if we were actually running it in Spider, nothing would happen because it needs to be printed out. And I'll go over that in a second. We could also do this, print F3. So here what's happening, we have a built-in function called print, and the argument to this built-in Python function called print is our user-defined function f. And this user-defined function f takes the argument 3. So the first thing the Python compiler is going to do is it will evaluate this. And what will be replaced by this? When the function returns after doing its work, this will be what, right? Okay. So because inside we had our user-defined function.
What's the difference of defining or of using print rather instead of just typing out?
Oh no, because this is, look at this. It does this. That's what you're asking, right? Okay.
Yeah, but why type print?
Oh, because here we don't have to, because here we are in the REPL loop.
So just type f of 3. If you type f
Yeah.
of 3, will it still give you back 6 or return 6?
Yeah. All here. So what should we send? I'm going to send in 16, so I can test your multiplication powers. Now, now we have the function definition right here.
Yeah.
We have the function call here. So I'm going to comment here, and you do commenting with the pound sign. You say function def lines, these first 3 lines. This is the function definition. And down here is our function call. Okay, so now I'm going to hit run without debugging. Okay, what happened? So the output should have come between these green lines and this line with
And
the
it should have
cursor.
been 32, like z equals 32.
It should have shown right here 32. If
Yeah,
go,
you know why?
Yeah.
Oh wait, never mind. You used z and x correctly. Never mind.
Okay, so it's not because we made a mistake.
Oh, thank you.
God bless. So here our function is defined, right? Now we're on the interactive session with Python. Our function is defined here. So and here I'm doing the function call. If I hit enter, 32 will show up.
Yeah.
Because it evaluates whatever it is and prints it out here to the display directly.
Okay.
Here, when we're writing a text, and this was written into example 14, we have to, this function call does happen, z gets returned, but it doesn't go to the display. In order for us to pipe it to the display, we have to tell it when we're doing this from the IDE. So we have to write this. Oh, 16.
Yeah.
Okay. So now we have 2 functions. Function call number 1, and now we have the function call 2 inside the print.
Okay.
So when the compiler comes to line 8, it goes back, uses 16, and calculates 30 and throws it away.
Okay.
Then, so once it's done with this line and then compiler gets here, it goes in, evaluates this to 32, and then passes 32 as the input to the print function, which then prints it out to the console down here. So now let's run this. And you can see 32 is right here.
All right.
It's all this mess here, but that's where the output comes.
I see that.
All right. So that's the difference between interactive Python, where everything gets evaluated and you see whereas if you want to see, and here, let's just quickly look at this. This is the keyword you need. This is the name of the function. This is where the parameter argument is passed in. This is the first statement. This is the second statement. This is a function call. And when the function is called, X gets assigned the value. Okay. This is what I've been talking about earlier. So we have print, we have a double function that takes 3 and multiplies it by 2 and returns that. So what happens literally is when the compiler reads this line, before it can do the print operation, it needs to evaluate the double 3 and bring it to the literal that this function call represents. And the literal that this function call represents is the 6.
Okay.
And then the 6 is passed to the print function, and then print function takes the literal 6 and pushes out into the display area. Okay, let's just go over this without. So they, all right, let's do this again. When the compiler comes to print, it prints greeting from the function, and that shows up in the text console in the Visual Studio Code IDE. When the compiler gets to this and executes this line, nothing happens except that X now, X, the reference variable, points to what after this line gets executed by the compiler? Jack?
X points to
What number?
print, so it's 11.
11, very good.
Yeah.
And then when the compiler comes to print X, that's why X now has a value 11.
Okay.
If
Because
this
it's
statement-
returning that. Okay.
Yeah. If this statement was missing, this function would not work.
Okay.
Put it. So when the compiler comes, it says, okay, this is the function, remembers it. Then it comes to the function call. It says, oh, okay, I need to go run this function. So the compiler moves up, prints this out, which shows up here, and it's the wrong spelling because this is the Germanic spelling. And then it tries to execute this statement, and you get that trace back, you get the error.
Okay.
And it says the error is a name error because the name X is not defined.
Ah.
So how do we fix that? We define it, we give it something. Let's make it into, well, it's defined now.
Okay.
Now, when I run it, well, it's defined now. So I'm going to delete this, okay?
Okay.
And I'm going to ask you this. Now, if I run it, what happened? The greeting got printed out, right?
Sure, but nothing from and
Nothing.
X did.
Right, because, and then it tried to execute print X, it didn't work. Now, I'm going to move, because X was not defined, right? It was the name that was not. I'm going to move this below as they say. Okay, now we have print X. It's going to croak on this,
Okay.
and it won't get to this because now, well, what's going to happen? Nothing, just error message.
Yeah.
As you can see, no greeting anywhere. The
Yeah.
greeting should have been here, and then the error message. If I
Okay.
switch them around, greeting would have got printed out.
All right.
Okay. All